Okay, so rule number 1 in the IUPAC naming system is find the longest chain. So what's the longest chain of this molecule? 8. 8, 7, 6. I think I'm hearing 3 numbers. Am I hearing 3 numbers? 8. Someone thinks they have a chain 8 long. 1, 2, 3, 4, 5, 6. That's 6. Is that the longest chain? No. 1, 2, 3, 4, 5, 6, 7. Is that the longest chain? No. 1, 2, 3, 4, 5, 6, 7, 8. Longest chain. Right there. Okay, let's scope that one out. So our longest chain is here. 8. So what is the prefix for 8? Oct. Is this saturated? So this is an octane. Octane. This is the major component in the gasoline in your gas tank. 8 carbon molecules. Octane, isomers of octane. So 5, 6, 7, 8, 9, 10 carbons long. That's the cut of gasoline. It's the kind of molecules that are in gasoline. You're not going to have a lot of methane in gasoline. Methane's a gas. It actually would bubble out of there. Propane, your gas tank gets a little warmed up and it's going to get pressurized because it's got a low boiling point. Propane, butane, pentane, but then you get into hexane, octane, heptane, octane, nonane, and now the boiling points are low enough that it's a liquid. We already did that one. What happened? Okay, now, rule numbers 2 and 3. Identify and name substituents. Number the carbon atoms in the chain starting from the end closest to the first substituent or branch. So this is what we're talking about, a substituent, something that's along that longest chain. So, well, let's do that one before this one, which was a little simpler. Okay, we got this one, 1, 2, 3, 4, 5, 6, 7. We said that's heptane. And what we left off is this right here. What substituent is that? That's a methyl. So we got the parent name, heptane. We have a methyl right here. Which end is it closest to? This one. Okay? So that's going to be carbon number 1. It says find the end closest to the first branch or substituent and then start numbering your carbons. So that's going to be carbon number 1. That's going to be carbon number 2, 3, 4. I'm not numbering the substituent. I'm numbering the longest chain. With me? And we got a methyl group. And what carbon is it on? Carbon number 3. So this is 3-methyl heptane. That's the name of that molecule. 3-methyl heptane. 3-methyl. We always put a dash around numbers. And you can see the heptane, there are 7 carbons here. Methyl, there's 1 carbon here. There are 8 carbons in that molecule. And we've accounted for all 8 of them with this name. This name only accounted for the longest chain. So we have to include now in the name the things that were not included in the parent name. Okay, so that's rules 1, 2, and 3. Okay, now, you work on this one, and let's take a 10-minute break now. So we'll break from now till 5 to 2. But name that. In the meantime, you name that. Go back to the longest chain. Remember, it's 8 carbons long. This is the longest chain. So we have left those out.
That's why I just put it next to me. I have blue, but I said they might get
No, that's fine. And what you see, okay, you did it right. This one is closer to that end than this one is to that end, so you start at 1. So we're going to put the ethyl before the methyl. That's all. Other than that, you're right on the money. First substituent, regardless of what it is. All right, so this is this one is closer to this end is closer, or this is closer to that end than this is to that end. So you got to go 1, 2, 3, 4 to get to that. 1, 2, 3. Yeah. So we want the lowest numbers. The lowest numbers. And then the only other thing, there would be dashes front and behind the number. Here, you don't need a dash in front of it, but when a number falls between two words, you put a dash on both sides of the number. Okay. I said 5 till, but not too many people felt like they needed a break. I guess a couple did. Okay, we'll give a few more minutes for them to come back. Oh, I can see that. I am going to have this vacation. My legs are going to kill me. By Friday, it'll be crazy. So let's take a look at this one. We originally said there's an 8 carbon chain is the longest chain. All right, so we have that chain. And we have over here, what is that? That's a methyl group. So it says find and identify the names of the substituents. What is that? That's an ethyl group. Okay, now the next thing we got to find is carbon number 1. We have to decide where to start counting carbons. We've got an 8 carbon chain. It has 2 ends. It has an end there. It has an end there. We want to start counting from the end closest to the first branch. What end is that? Up here. Because see, if that's number 1, 2, 3, this is on carbon number 3. If I call this carbon number 1, 2, 3, 4, I don't get to this until I get to carbon number 4. All right, so that means this is carbon number 1, and that sets the numbering of every other carbon. All right? So now we know the number of every carbon, 1 through 8. All right, so now we have a methyl on carbon number 3. And we have an ethyl on carbon number 5. We'll come back to this in just a second. Let's look at the last 6 rules. Designate the location of each substituent by a correct number and name. Assemble the name, listing groups in alphabetical order. Use prefixes di, tri, or tetra when there are more than one of the same substituent. And rule number 6, ignore those prefixes. Ignore the di, the tri, and the tetra when alphabetizing. So you don't alphabetize off of those things, you alphabetize off of the name of the substituent. Well, this molecule we have back here doesn't have any prefixes in it because there's only one methyl, there's only one ethyl, but which one comes first in the name? Ethyl. We're going alphabetically. So the ethyl is on carbon number 5. So let me get that ethyl out of there. So it's 5-ethyl. The methyl is on carbon number 3. 3-methyl octane. And I'm not too hung up on whether the ethyl or the methyl are capitalized or not capitalized. Get them in the right order, alphabetically. You should be putting dashes between, and why do you have dashes there? Well, you can see this word ethyl ends with an L. Kind of looks like a 1. How would I know that's not a 1? Well, this dash helps me see if I ever have a 1 in a name, I'll actually have a dash on either side of it. But I won't have to do that with an L, okay? So that's part of what it's doing. It's helping us distinguish numbers from letters. And that's the name. That is the IUPAC name of that molecule. 5-ethyl, 3-methyl octane. Now, I'll tell you what I'd like to try to do. I try not to go past 2:15. 2:15, I'm going to hand out the homework, and we're going to do a couple of them. The very first question has 12 molecules that you do: a condensed formula, line formula, structural formula. So we'll pick one of those out of there and do it, so you actually know what this should look like. And then you can either work on it for another 10 or 15 minutes, or we'll be dismissed, something like that. But I want you to get going on the homework. Okay, these are all alkanes. What is the longest chain? Anybody get higher than 7? Okay, 7. So something like this. That gets 7 carbons. All right, so what you can do there then is then see what you're missing. I don't know if this one's going to come out to be the same as what we just did, is it? Oh, it's 7, so it's heptane. Yeah. So this is heptane. Running out of power. This thing usually gives me about a 15-second warning. Isn't that great? Maybe not. All right. So that's heptane. we have this one nailed down? Where's carbon number 1? Over here. 1, 2, 3. Yeah, 1, 2, 3, 4. Yeah, this is looking a little bit similar to the other one. So there's 1, 2, 3. This is 4, 5, 6, 7. Yeah, so it doesn't matter whether you come from this end over to this one or come from that end over to this one. It's going to be on carbon number 4. But it does matter to this one. If I started up there, this would be carbon 5. But here, it's a 3. So we're going to always opt for the lower set of numbers in the name that we can get. So it's going to be a 4-ethyl, 3-methyl heptane. What? Well,
from the closest to number 1?
yeah, so 1, 2, 3.
3-ethyl, right?
That's a methyl.
Oh, you're right.
That's a methyl.
See the other one?
Yeah. Am I right? I'm not always right. I'm right often enough that they let me keep teaching here, but I'm not always right. Yeah, so and particularly if I stand up here and teach for 3 hours, there's going to be some froggy moments. All right, we got it? Is that you getting this? I know it takes a little time. You're going to have to do a lot of naming of molecules. It's going to have to become second nature. All right, now, okay, let's go back for a moment. I told you there are going to be 6 substituents, and so far we have, let's see, where did we leave off with our substituents? Right, okay, right about here. Okay, so I tell you what, just right underneath here, I'm going to get to the other 2. So let's kind of list our. We got a methyl, we got an ethyl, we've got a propyl, and this could also be called normal propyl or N-propyl. We have isopropyl. Okay, so the next one would be butyl. And butyl is going to be, or normal butyl, and what you might expect, it's going to be 4 carbons right in a row. This is butyl. Butyl, 4 carbons, has about 4 different substituents it can have. The 2 that I want you to concentrate on are butyl and another one called tertiary butyl or tert butyl, or most often it is just called T-butyl. These are all one and the same substituent. What happened? Sorry about that. T-butyl. They're all on the one and the same. Now, because you can see the word butyl, it's going to have 4 carbons. All right, but what are they going to look like? They're going to look different from this. This is your normal butyl. 4 carbons right in a row and a place right on the end that it could attach to. Well, this one is going to have a carbon there. It's going to have a carbon there. It's going to have a carbon here with 3 hydrogens on it. And it's going to have a carbon here with 3 hydrogens on it. And here's where it's going to attach. It's like a T. It's tertiary butyl. Kind of like a T. All right, 1, 2, 3, 4 carbons. This carbon has no hydrogens on it. This is the one that's going to attach to the chain. So make 3x5 cards for those 6 methyl, ethyl, propyl, isopropyl, butyl, and tertiary butyl. Do 1F. Well, I'll tell you what, we'll do one, let's do a simple one. Let's do 1D and 1F. But let's do 1D first. It's simple. Because you're doing this the first time. Okay, everybody have one? Let's take a look at 1D. And it talks about, so the name of this thing is 2-methylbutane. And it wants a condensed. Now I'll tell you what, we're going to start out with structural. So I'm going to just condensed, structural, and line. I got them lined out like that. Sometimes it's easier for you to put the line right underneath the structural, but let's start out with structural. And how would I approach, given a name? What we've been doing so far, I've been giving you structures and saying, how do we name this? Now here's a name. It's a structure. We'll start with the parent name. Butane tells you how many carbons are in this thing. 4 carbons. 4 carbons is the longest chain. It's not how many carbons are in it, but that's the longest chain. So get yourself a chain of 4 carbons. And don't do anything more than that right now. 2-methyl. So that tells us there is a carbon, and in this case, since we're drawing the structure, you can do the way you read in a book. You read from left to right. You can say, okay, I'm going to count from left to right. Someone's not giving me a structure, they're giving me a name. So I'm going to say that's carbon number 1. So if that's 1, that must be 2. And I'm going to put a carbon on it. And that is actually a methyl group. All right? And then just come walking across here and say, okay, how many hydrogens do I need to put on that carbon? I need to put 3 hydrogens there. How about the next carbon? 1. You see that carbon's attached to 3 carbons, so it only needs 1 hydrogen. How about the next carbon? 2. How about the last carbon? 3. Okay, so put your hydrogens in last. Don't draw it out there and start slapping hydrogens around. You don't know how many hydrogens go anywhere until you get all the substituents in their right place. Okay? So now condensed is over there, but let's do the condensed right underneath it. Well, you want. I'll do it right underneath it. You can have a little scratch paper however you want to, because see, why do I like to do it right underneath it? I can come over and I can look at each carbon and say, what does that need to look like? This one is a CH3. This second carbon is a CH with a CH3 on it. And the third carbon is a CH2, and it ends with a CH3. There's your condensed formula. Line formula. Remember, when you put your pen down, 1, 2, 3, 4. And there's a methyl group right there. A methyl group is another straight line. There's 2-methylbutane. Okay, on a scratch piece of paper, try to do 1F. On your notes, try to do 1F, and then we'll do 1F. And we'll do it, and you can put it in. Any questions about 1D? Everybody with that? You guys are already experts. 1F is 3-ethyl 2-methyl hexane. What you're doing. If I shake my head no, you're on the wrong track. Start. Yeah. Doesn't matter. It just has to be on the second card. And that's what has to be on. You're going to get the same condensed one. You don't draw, you don't put the C on the bottom. You all start with Yeah, it doesn't matter. So that's carbon number 1. It doesn't matter either. If I took yours and turned it and flipped it, it would fit on top of hers. Yeah, okay? So they're the same molecule.
Well, you prefer those?
No. 1, 2, 3, 4, 5, 6. So finish off your hydrogens. Finish off all the other hydrogens. Put all the hydrogens around the hexane. Get the methyl and the ethyl group on there, and then all the hydrogens. Okay. Is everybody there? Yeah. That's good. That's good. Okay, now what do you do with the line? Yeah, see, in that line, I would think that's a methyl. I'll show you. Okay, let's finish this off. So hexane is 6 carbons long. And there is a methyl on carbon number 2. And there is an ethyl on carbon number 3. And then I need to finish off my hydrogens. And now people have been asking me, does my methyl have to be on the top and the ethyl on the bottom, or vice versa? They could both be on the top, they could both be on the bottom. The methyl could be on the bottom, the ethyl on the top. It doesn't matter. It just has to be on the right carbon. And it comes back to this fact that this can rotate. So let's say I had a methyl group right here. Let's say I had a methyl group right there, and I had it on the top and the hydrogen on the bottom. I could always rotate it. And, I could always rotate it and get the methyl on the bottom and the hydrogen on the top. I haven't changed the structure. I've just changed the rotation of it. You don't have to start on the left counting as carbon number 1. You start on the right. Just make sure your methyl is on your second carbon. Those molecules are superimposable on one another. So then the condensed formula, we kind of know what to do there. And then over here we're going to have a CH, and let's see, there are 2 ways of doing this one. There's a CH2, CH3, that's an ethyl. So let's do it that way for right now. That's my ethyl. Then I would have a CH2, a CH2, and a CH3. The other way to do that would be a CH2H5. That's also an ethyl. So you'll see it probably both of those ways. Okay? There's 2 ways to show that in a condensed formula. Okay, now the line formula is a little tricky. A little bit tricky. We got 6 carbons, so here's 1, 2, 3, 4, 5, 6. A methyl, that straight line going there is going out to a carbon that has 3 hydrogens on it. Here, that is a methyl, but that's an ethyl. You got to put a bend in it. Just like if you drew the line formula for ethane. No, ethane won't have a bend in it. It'll just be a straight line. So forget that. But I can't just put another straight line here, and I can't just put a longer line. You say, well, I'm going to just make a longer line. Well, I don't know if you meant that to be longer. I don't know what longer means. Okay? Just a straight line is a methyl. An ethyl's got to have a bend. Okay, everybody have that? And, okay, let's just look at this assignment. And so what you can do for tomorrow, what I would say you do, yeah, you can do problems 1, 2, and 3. And we will finish chapter 10 the first hour, maybe 11:30 to 12:30. I'll try to finish chapter 10 and give you at least, well, I'll give you 20, 30 minutes to finish this homework, which would be questions 4, 5, and 6, and 7, and 8. We'll get into reactions. Now, yeah, we're going to talk about isomers tomorrow. We're going to talk about cycloalkanes, cyclical alkanes. We're going to talk about isomers and then reactions. Combustion, like I told you, the most things we do with this is burn them. And halogenation. How would we put a halide onto an alkane? How would you write the chemical reaction for that? So if you want to delve into that, it would be the rest of chapter 10. Any questions? So if you do the first 2 pages, we'll finish the 3rd page in class. You should start reading chapter 11, alkenes, a little bit. Get into, we'll do, so we're going to finish chapter 10, finish this homework, and then probably do half of chapter 11. We probably won't get to alkene reactions, but we'll get to what are alkenes and how do you name them, and how do you draw them, and all that. Questions? And then a what? Oh, yeah, over here? Yes, you can. What's your name? Alejandra is saying, could I put a parenthesis here and put 2 of those? Yes, I wouldn't, if there's just 2 of them. I would stay away from too many parentheses unless, like decane, this is Alejandra's, it's like decane, you could write this way. All right? That's a good use of that. Yeah, I mean, why write 8 of those? You can bunch that together and say there's 8 of those CH2s. But my personal preference, I don't like these to get too complicated, then I get confused. You know, it'll confuse you. Use it when it makes sense. Putting parentheses in the 2, you could write that. You could already write that. And it shows you your 1, 2, 3, 4, 5, 6 carbons right there. Staring at you.
But if there is a long one, then...
Yeah, if it's a long one, you can bunch them together. Yes.